8, 7 intercepts. I think this is the point where we have coordinate planes and graphing lines. I think that this is the part where it truly becomes easier. We're going to do a couple of things that we've done in the past. We're going to be recognizing some slope, and then I'm going to show you a really easy way of doing this. So we have intercepts, section 8, 7. The x-intercept is the value in which a line crosses on a graph. The x-intercept, let's try to actually have a pen out. There we go. Whoa. X-intercept. X-intercept. And in football, when you have an interception, it's when a ball gets intercepted by the other team. Yes, sir? Yeah. And the y-intercept is a value which a line crosses the y on a graph. Y-intercept. Y-intercept. So where it crosses on a graph the y-coordinate. What's that? Yeah, where the ball and the player meet. Exactly. So at the graph below, label the x and the y intercepts. So here's the y. Here's the y on the graph, and this is where it crosses the y. So what are the coordinates? So the y, let's get it bigger. Y-intercept. What are the coordinates of the y-intercept? 0, 2. And then the coordinates of the x. The coordinates of the x-intercept. It's going to be right here. We have negative 4, 0. Negative 4, 0. So to find the x-intercept of any equation, you set the y value equal to 0. So we're going to substitute 0 in for y. So I'm going to make this y here 0. So it's when y equals 0, 0 equals 3x minus 6. Now we do reverse order of operations. Please excuse my dear Aunt Shaniqua, but we're doing it backwards, so it's sad mep. So first off, do we have any subtraction? Yes, we do have subtraction. That's the first one, so we have to do the opposite of subtraction, which is addition. So I'm going to add 6 to both sides, and this is nothing new. This is actually the third time of us doing this year, at the very least. So I have 6 equals 3x. Now I got to get x by itself, so I need to ask myself, what is happening to x? Gersh? Divide by how many, Hopwood? 3. So I'm going to divide by 3. Divide by 3. So now I have, I'm going to go up here, x is equal to 2. So I have found my x. I still have my y as 0. So what would those coordinates be as an ordered pair? Wes? 2, 0, exactly. And we're going to use that again later on. 2, 0. Did I hit record? Okay. 2, 0. Now find the x-intercept of that number. So I remember I have to put y is 0. So 0 equals 3 plus 0.5x. I'm going to do reverse order of operations. Now this one here is an example of what the quarterfinal really messed up a lot of us. What's happening to x? What's happening, Adam? Anything else other than being multiplied by 0.5? Good, it's being added to 3. So how do I make the added to 3 go away? Subtract it. Now this here is a positive 3. So to make a positive 3 go away, I have to subtract 3 because that's a positive 3. So I have negative 3 is equal to 0.5x. Then I have to divide by 0.5 because the inverse of multiplication is division. And whenever I divide by a half, it's the same thing as multiplying by 2. And because I'm recording, I'm going a little bit faster. So if anybody does watch this again, they're not sitting through time that we don't need. Hi. Yes, I don't want the sign book. So we have our x value, we have our y value. What is the ordered pair? We have x right here, and y is 0, so negative 6, 0. Negative 6, 0. That is where it crosses the x-axis. That is where it crosses the x-axis. Now we're going to find the y-intercept. And in order to do the y-intercept, we put the x value to 0. So when we're finding x, we make y 0. When we're finding y, we make x 0. Yes, sir? Y is always the dependent variable. X is always the independent variable. Yep, because if you can change x, and that will make y different. Good question. So I'm going to make the x value 0. So x equals 0. So I'm just going to substitute this here. Y equals 3 times 0 minus 6. And that comes out to be y equals negative 6 because multiplying by a 0 is so hard. And my ordered pair for that one is going to be 0, negative 6. This one here is the same exact as the first example we did, by the way. That equation, y equals 3x minus 6. Before we were finding the x-axis, now we're finding the y-axis. With what? No, because we're finding the y-intercept now. Look what we did on the page before it. We found the x-intercept. Yep. Now find the y-intercept of that guy. Once again, I'm going to put x is equal to 0. So I have y equals 3 plus 0.5 times 0, which is just simply y equals 3. And the ordered pair is 0, 3. Once again, for those watching at home, I'm getting my x value from here, my y value from there. Now let's find them by graphing. Let's check by graphing. What was the y-intercept of this here on the front page? Or on the second page, whatever it was. What is the y-intercept of y equals 3x minus 6? Garrison, what is it? Ah, yes. Follow along, pay attention. Gershi, what is it?
Negative 6. Or over, would you say?
The coordinates. What are the coordinates?
0,
0.
6.
Is it negative 6?
Yeah.
Okay, good. X-intercept for this one, where y was 0, so it'll be something 0. Weber? 3. 2? 2. 2. So I'm going to find the y-intercept. I'm going to graph those points. 0, negative 6. 0, negative 6. oops, wrong button. 0, -6, and 2, 0, 2, 0. So I'm going to connect those 2 points now. Because what's the minimum amount of points that you need to make a line? Correct, just 2. And so we're going to put those 2 points on the line, and that looks good. I could check it if I wanted to by doing, looks like it goes through that point. So if I want to put 3s in there to check my work, 3. And yes, 3 equals 3, so that checks. What I did just then is I checked this point here just to make sure that I'm doing them right. But you don't have to write that part. Now the other one that we did, my y-intercept, my x-intercept. I always know that the other ones are going to be 0 on that. So what was my y-intercept for 3 plus 0.5x that we found in the previous pages of our notes? Wilgus? 3. And the x-intercept? What you got? -6. It's just above what we just did. And for those of you who are not back into school mode, you're still wishing it was spring break, where we got these numbers, where we got this y-intercept for 3x minus 6, we did it over here. The y-intercept for 3, sorry, the x-intercept. Did I point? Yeah, the y-intercept is at the bottom. There we go. At the bottom. It's from the previous pages of the notes. Here's the y-intercept here for this one. Because, oops, this is right here. And also right here. Just to put them all together. Are there any questions so far? A quick way to find a line. Yay! Uh-oh. It's okay, she's still living. It's busted open, but it's still living. Okay. Temporary setback here. I don't know. Okay. And we're good. Microphone. So if you're wearing headphones and you just had that, I'm sorry, I dropped the microphone. All right. Quick way to find the line. Slope-intercept form is y equals mx plus b. Y equals mx plus b. That is the slope-intercept form. The m in this situation represents the slope. That's from last Wednesday that we were in class. Which is the change in y and change in x, which is rise over run. Rise over run. Change in y over change in x, rise over 1. Okay. And b represents the y-intercept. B equals the y-intercept. Chrome, please don't. He's trying to get away from you rather than telling you to stop. So sit up, please. So let's do that using the slope-intercept form. So once again, just because I can't see it, I'm rewriting it. Actually, I'm going to write it right above it. So what is my slope here? M is equal to, what is my slope? What is my m? Yeah. 2. It is 2. Because look, we have m here, and there's a 2. Then we have plus b, and we have a minus 1 there. Because remember, if I had it plus b, keep in mind that 1 plus negative 1 is the same thing as 1 minus 1. Okay? So my b value is negative 1. Austin, just take your shoes off of his desk, please. I'm not asking for a response. Please take your shoes off his desk. Days. All right. We have b is negative 1. That's where my y-intercept is. So I go on my y-intercept, and I do negative 1. My slope, if you remember, is rise over run. If I were to put that into an improper fraction, that would be 2 over 1. 2 over 1. So it's rise over run. It's a change in y over change in x. So if I'm changing y, I'm going a positive 2. That means I'm going to go up 1, 2, and over 1. I lost a lot of last period here, but they followed me after the second one, so I'm going to say it again. Since this is rise over run, as you guys just wrote down right here, change in y over change in x, rise over run. It's rising a positive 2, so it's 1, 2, and it's running a positive 1. So my change in y is 2, my change in x is 1. Yes, ma'am?
So every time that, do you put m in an improper fraction every time to know where you graph?
I would recommend putting m in an improper fraction, exactly. Yep. Yep. So since I have 2 points, and the least amount of points that I need to make a line is 2, I use my school-issued straight edge, also known as my ID, and I draw a straight line from those 2 points. All right. Let's do another one. I don't know if it's... You guys feel good about slope, though? Feel decent about it? Good, good. Yeah, that was the last Wednesday that we had class. That was the last Wednesday that we had class. So I have, once again, y equals mx plus b. I'm rewriting that because I can't see it right now, and I want to make sure I don't make any silly mistakes. So what is... I'm going to get a different color here, you can see better. What is my y? I'm going to do it as b. What is my b? What is my y-intercept? Kennedy, what's my y-intercept? The number that's chilling by itself. Yep, 4. My y-intercept is 4. And my slope, this one's not as obvious. My slope, let's get someone I haven't heard from today. I've heard from you. Ms. Wyatt? 1. Yeah, it's 1. Good. It's 1 because keep in mind that 1 times x is just x. So now I have those 2 points. I have my slope-intercept, which is 4 is my y-intercept, and then it's a 1, which is just 1 over 1. So it's up 1 over 1, up 1 over 1, up 1 over 1. Yes, sir. No, that's why you guys use your IDs and you can draw a straight line. Draw a straight line with this. And that's not perfect. I want to make that a little better. There we go. That's a little better. Now with this one here for number 3, it's not in slope-intercept form, so that's the first step that we have to take. First, we have to put it into slope-intercept form. So go ahead and write that down with the star next to it. So when you go home tonight and you work on your homework, you're like, I don't know how to do this. You can look at the star. We need to put it into slope-intercept form. Which means that we just have to solve for y. Adam? Were you going to say that? Oh, sorry. So we're going to solve for y. 2x, or negative 2x, plus y, and this one is nice and pretty, equals 3. So you have to ask yourself, what's happening to the y? What's happening to the y here? West, what's happening? It's being added to negative 2x. So how do we make that negative 2x go away? Kenna? Add 2x to both sides. Beautiful. Add 2x to both sides. So in the past, when a lot of the students were concerned about maybe struggling with solving equations in the past, this is the reason why I would tell you and your parents that it's not too much concern yet, because this is like the 4th time that we've gone over this. And I truly feel, and I hope you feel the same way, I truly feel that every time we do this, you're like, oh, okay, I remember doing that. Or, okay, I recognize that. And after all, it's like, do I do that here? And then we do that. And you're like, oh, got him. So now I have it in the slope-intercept form, y equals mx plus b. My y-intercept, which is b, is 3. My slope is just 2, which is the same thing as 2 over 1. 2 over 1. Two over 1. So I have my y-intercept is 3. My slope is 2 over 1. Rise 1, 2 over 1. Rise 1, 2 over 1. I get out my ID. I line up the lines. There it is. There. And there's my solution. Every single point on that line would make it true for negative 2x plus y is equal to 3. Here we go again. It's not in slope-intercept form, so I need to make it into slope-intercept form. So I need to solve for y. 2x. I need to use SAD-MEP. Oops. Plus 9, 2x plus 9. It's being multiplied by 3, so I need to inverse of that, which is divided by 3. Y equals 2/3 x plus 3. And what I did is I just distributed that divided by 3. That was from very end of 3rd quarter. So now I have my slope-intercept form. The b is just the one that's chilling out here. B equals 3. My slope is already in a fraction, 2 over 3. So we're going to look at 3. So once again, my slope-intercept for the y is at 3. Then I have 2 over 3, which means I'm going to go up a positive 2 and over a positive 3. So up 2 on the up 2 on the y-axis, over 2 on the x-axis. So up 2, 1, 2, over 3, 1, 2, 3. Up 2, 1, 2, over 3, 1, 2, 3. I did 3 points. You only need to really do 2. And there's my solution to that guy. Now, because it's on your homework, similar to this, if I had a line that was like this, if I could get it to be, there we go. If I had a vertical line like that, what's my y-axis, or my y-intercept? If there is no slope there, because it's a vertical line, where does line F cross the y-axis? It doesn't, so you wouldn't have one, okay? It does not, so you wouldn't have them. So on the homework, when you see that, that's what happens there. So for this one, what I'm going to do is I'm going to take my y values. I'm going to increase those values. I'm going to make the y values have 10s there. So that's 10, 20, 30, 40, 50, 60, 70. So please do that. Please put zeros next to those so we can actually have it fit. All right. A daycare costs $30 for registration and $20 per day. Make an equation using C for the total cost and D for the number of days. So C is equal to, I have 30. Now, can I avoid paying that 30? No. So it's going to be plus 30 no matter what. And that's going to stay. That's the constant. Then we have $20 per day. And in that situation, whenever you see per, it's going to be multiplication. So I have 20D. So that's 20 per day. So that's the equation for it. And now we're going to graph that. Even though it's not using y's and x, do you see how this is the slope-intercept form? Okay? It doesn't have to be x. It doesn't have to be y. Just C is going to be the dependent variable, and D is going to be the independent variable. So we've added those zeros in there. So I'm going to find my y-intercept. B is going to be 30. My slope is going to be 20, which is the same thing as 20 over 1. Because once again, I'll rewrite this, y equals mx plus b. So I have my y-intercept. I'll get a different color. Y-intercept is 30, and it's going to go up 20 and over 1. So I have up 20 and over 1, up 20 and over 1. And I have 3 points now, so I can use my school shoot straight edge and draw a straight line. Now, in our graph, we wouldn't be able to see it because it goes up at such a high rate. And also, you wouldn't have a negative money, but this is just for demonstrative reasons. A daycare wouldn't pay you to put your kid there. So, according to your graph, what would be the cost for daycare after 5 days? So, what I'm going to do is I'm just going to plug in 5 for the days. So the cost would be 100 plus 30. So it would cost me $130 a work week. $130 for 5 days of care. Yes, child care is very expensive. Are there any questions since we're done? Okay.